Okay, so now let's do the same example, but let's change it from what we'll do right now. We will calculate the exact same thing. So what we want to calculate is the position and velocity. But now, well, yeah, we'll still t equals 1 second, 2 seconds, 3 seconds, and finally the time it takes time to reach the ground. Okay, I don't know if you remember, but on the last example, which was exactly this example, we took our reference to be this point. So we said that at this point, this would be my original position, and we called this reference point my origin. So my original position is at 0. Now what we'll do is something that some of you might make a little bit more sense. We'll take the ground as my reference frame. So here is y equals 0. Therefore, this position right here is y0 equals 57 meters. Right? Because I am 57 meters above ground, right? My y at this point is 0. We also established that the positive direction of y is upwards. And that is basically it. That's the only thing we changed from the last example. Our acceleration, since we're on Earth, it's still the same, minus 9.81 meters per second squared. My original velocity in the y direction, since I am not throwing this up or down, I am simply just letting it go, is 0 meters per second. Now we can use our both equations that we used in the past example, but now the only thing that has changed is this value right here. That's the only thing that has changed. So let's do that and let's see what comes up out of the equations. So these are our two equations, and now we want to find the position at the ball at t equals 1 second after we let go of it. So y, which is position, is equal to 1/2 times negative 9.81 meters per second squared times the time squared times 1 second squared. Put this just to be strict. We know that it's 1 second squared is still 1 second, just to be strict, plus my original velocity, which is 0, times the time, which is 1 second, plus, and here is the only thing that has changed from our past example. My initial position now, we are at 57 meters above ground, above my reference point. So positive 57 because we are away from it, okay, in this direction. So is 57 right here. So if we calculate it, this is equal to y is equal to negative 4.905 plus 57, and that is equal to, let's use a calculator because I am not good at math, so 57 minus 4.905 is equal to 52.095. Okay, so 52.1. So at 1 second after I let go of my ball, the position of the ball is 52.1 meters above my reference point, above the ground. Now, we need to find the velocity of the ball, this time at t equals 1 second after we let go of it. So now we use this equation right here. So the velocity is equal to my initial velocity plus my acceleration, which is negative 9.81, times the time, which is 1 second. So my velocity is negative 4.905 meters per second. Okay, this is exactly the same value. So what I did now is I calculated the values at t equals 2 and 3. I used Excel again, so So here at 0, look, I changed this. At 0, my y position is 57, right? And my velocity is 0. I am not throwing this either up nor down. At 1 second, look, I calculated and it is exactly the same here. Oh, sorry, I made a mistake here. I don't know why I did this. 9.81, yes. Sorry. So at 1 second, I am at 52 meters above ground, and my velocity is negative 9.81. At 2 seconds, I am at 37.38 meters above ground. My velocity is negative 9.62. And at 3 meters, I am at 12.85 meters above ground at minus 29.43 meters per second. So let's just do a quick comparison between these two. So these are the results from the first example. Let me just paste them here. I just want the numbers. Where are the numbers? Formula values. Okay, just paste the values. So those are the results from the first calculation, and these are the results from the second calculation. Remember that I am only changing my reference frame. Okay, that's the only thing that I'm doing. So look, so let me add here another column. I mean row. Let's make this pretty, like that. Merge. Let's use example 1, and right here we'll have example 2. Okay, so with our reference frame at the ball, at the height, so the initial y position 0, after 1 second has passed, I have moved away from my original position 4.9 meters, right? If you look at this, example number 2, I am taking my reference point as the ground. So my original position is 57 meters above ground. After 1 second, I am 52 meters above ground. These two values are exactly the same value. Exactly the same value. Even though they might not look like it, they are exactly the same value. And let me show you why. Okay, so at this point, so at t equals 1 second, let me put a white color here. So I'm going to exaggerate. Let's say that the position of the ball here is at, oh, that's a horrible circle. Okay, that's better. So this is at t equals 1 second. Okay, so let's see. Okay, there we go. Let's use this color. So on our first calculation, we said that after 1 second, the ball moved from this position to this position, right? And that position is negative. Let me use another color. Let's use red. So using the first example, I moved from here to here. And this was negative 4.9. Negative 4.905. And with my other example, with example number 2, the distance that I am actually measuring is not that one, but rather this one right here. So I am saying that this position is 52.905. 52.905. As you can see, these two positions are exactly the same position, right? Because the first number is telling me that I am 4.905 meters downward from my original position. So from here, this was my 0. On my second example, since I established my 0 here, I am saying that I am 52.905 meters away on the top, like upwards from my 0. So if I do, for example, this, so if I say 57 plus this quantity, so negative 4.905, I get 52.095, this exact same position. So for example, if I also take 57 plus this position right here, I get 37.38, which is exactly what is calculated here. If I take 57 plus this value right here, I get 12.855. So if you can see, doesn't matter what reference point, what reference frame I am using, the calculations will give us the right answer. But you have to be super careful with what reference frame you are using and what quantities are the ones that you are measuring, right? So for example, if I used right here my reference frame here, the first value, the first calculation would give me the distance from here to here. But if I use my reference frame as here, I am checking the distance from my reference frame to the ball. So from here to here. So in the first case, the reference frame was here, and measured distance was from here, from my reference frame to the ball. On the second example, where the reference frame is here at the bottom, the distance that I am calculating is from the ball to my reference frame. So this value right here. Okay, so I hope this is clear because we'll be looking at this in class, but it's exactly the same thing. Look, I even did the scatter plot, the coin free fall, or it's not a coin, the ball free fall. This is position versus time. So as you can see, we start out at 57. See, I also calculated it in intervals of 0.2. But now this is more visually attractive. We can visually see where the ball hits the ground, right? Because it starts at 57 and it starts falling, 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 and it hits the zero around 3.4 seconds. See, around 3.4 seconds, which is what we already calculated, right? It should hit the ground at 3.41. So before I finish this video, let's do the quick math, but using the reference frame like this one. We want to know when it would hit the ground. So now instead of putting negative 57 here, since we changed the reference point to the ground, we want to know when it will hit 0. Okay, so 0 equals 0.5, sorry, of negative 9.81 times the time, which I don't know, time, so let's see, time squared, okay, plus my initial velocity, which is 0, times the time, plus my initial position. So here my initial position is 57, okay? So we pass everything to the left. We have negative 57 divided by 0.5 times negative 9.81, and all of this is equal to t squared. Oh, t squared. Okay, whatever. And that means that t is equal to 3.41 seconds. Right? So it doesn't matter that I change my reference frame from here to the ground. As long as you know what you are doing and you're working with the math, you're working with the numbers and the appropriate numbers, then you are completely fine. Okay, so this is example number 2. It's exactly the same as example number 1. I think with this is enough for theory for you guys to actually go into the class. Remember, we'll be working problems in the classroom. Okay, so thank you for your attention and have an awesome day. Goodbye.